Lesson 3.2, Video 1. Now before we talked about relationships and a relation. Now we're going to go further and describe that relation as being a function or not a function. Now the notation, or the term function is given to a relationship that has only one value of the dependent variable for each value of the independent variables. Now that's hard to understand in words, but if we make a graph, it'll probably make more sense. So let's try that. Or not a graph, we're going to make a table. So if I give you an XY table, and I give you values of -3, -2, -1, and 0, and we'll plug in some Y values, and let's say that's 5, and 4, 3, and 2. Now again, just a little reminder, that the X values are the independent variables and the Y values are the dependent variables. And again, just remember this is also the domain and this is the range. But we're focusing on these terms. So what they're saying is that for every independent variable there is only one Y value. Or excuse me, for every Y value there's only one X value. So to cut to the chase, if you're looking at a table, all the x's must be different in order for it to be a function. That's probably the easiest way to think of it. Now if you have a graph, then you can use what's called the vertical line test. But you have to be given a graph to do it. So if I gave you a graph and I gave you a parabola, I would draw a vertical line, and if that line intersects the graph in only one place, okay, only one place, then it is a function. However, if I give you a graph of a sideways parabola, like this, and I go and draw my vertical line, notice I intersected at more than one point, then it is not a function. That's what the vertical line tells us. There's also a perk to functional notation. So a function is just describing a relation if it's a function or not. A vertical line test is a way to apply the test on a graph to see if it's a function. But we also have what's called functional notation. And the notation is a little bit different. If you notice, what we normally have here in regular notation is we have y equals something. In functional notation, we have this notation, which makes or takes the y and replaces it with f of x, and that is how it is read. F parentheses x is f of x. And if you have a number in there, it's read f of 1. Now, interestingly enough, this is actually pretty straightforward. And what it's doing is, functional notation does two things. It gives it a name, so I can say that you have f of x equals 3x minus 2. I could also say, besides f of x, I could say g of x, or I could say h of x. I could say any of those things, and the difference just means it's a different name or label. Now that might not make a difference to you, but if, for example, if I had 3 equations and I said plug 2 into that one, and not really being specific as to which one, you wouldn't know which one to plug that value into. But if I said plug a value into the g of x equation, you'll know which function to use. Now if I want to plug in a number, I would say find out what f of 2 is, which means plug 2 into the f function. So it not only tells you which function to do, it also tells you what to plug in. So it gives you a name and it tells you what is being, and plugged is a very basic word, but we know it means substitution. It tells you what's being plugged in. So in other words, this notation, f of 1, means please plug or substitute a 1 into the function. And that's what you do. All right, this ends lesson 3.2, video 1.